Here we are with a special edition for linearization. To linearize means to straighten out a curved line. So as we'll see a little bit in this section and then definitely in the next lesson, all of our graphs are not straight, but sometimes we need them to be straight. So the purpose of this quick little video is to show you how to get the straight graph from your currently curved graph. So here we go. First we got to start off by identifying the constants and variables in your physics equation. Then we're going to line up the equation with our straight line equation. The straight line equation is y equals mx plus b, lining up the physics variables with x and y. What we're going to do is circle the independent variable and its exponents with x. This is what will go on the x-axis. And then we're going to circle our dependent variable and its exponents with y. This is what's going to go on the y-axis. Coefficients on the horizontal axis, variables are the slope, right? So the m term is your slope. Anything not in circles with the x but part of that same term. Any constant term added at the end is your y-intercept. So here, let's just use this random equation. Our constant is v and z naught. To get a line, what should I plot on the horizontal axis? Well, this equation is already solved in the y equals mx plus b format. So we'll circle the y's to be z and the x to be t. So we would, when I make this plot, what will be represented by the slope? V. What will be the y-intercept? Z naught. Here's another one, a little bit more challenging. But we have it solved to match up with this y equals mx plus b. And the reason why we do this is to give us a straight line. So on the y-axis we'll be plotting z. On the x-axis we'll be plotting t. Meanwhile, the slope of that graph will give us half of v, and the y-intercept will be whatever z naught is. Here's another one. Almost the same equation. Z equals 1/2 vt squared plus z naught. On the y-axis it's going to be z. On the x-axis it'll be t squared. And the y-intercept is z naught. Meanwhile m is 1/2 v. So what's the difference here? The difference is I also included this squared. So the graph of this curve is, or the graph of the original equation is going to have this concave up look to it because of that squared term. So by linearizing it, we're stretching it out. That means we need to have z plotted on the y-axis, and on the x-axis, t squared, not just t. Here we go. Still the same thing. It's very, very redundant. You can pause this video, slow it down. As you go through, you really start to get the hang of this. So if we had t equals pi times m, y equals mx plus b. T squared, guess what the y-axis is? T squared. As long as you have it set up in this same look, it's going to be the same every time. Y equals t squared, m times x plus b. Looks like on the x-axis I would put the m, and my slope would be 4 pi. T squared equals 4 pi squared times m. Our slope will be represented by 4 pi squared. The slope here is going to be 4 pi squared over k. Okay, so here's where it gets a little tricky. To do this, you have to remember that m, whoa, we don't want the line, freehand. M over k is the same thing as m times 1 over k. So this m up here in the numerator is going to be on the x-axis. Meanwhile, all of this other junk right here, 4 pi squared over k, because remember it's 4 pi squared times 1 over k. And when you get that, you get 4 pi squared over k. That is our slope. As an added bonus, we'll leave it at that. So go ahead and try this one. Pause it. Give yourself a minute. Nice and easy, right? Here's your hint. It's the same thing. It's the same thing. Separate out your constants and variables when the variables are in the denominator. It's the same thing over and over again. It's just y equals mx plus b. The trick is setting it up into this same format and separating out your variables if you do have a fraction. Separate your variables if you do have a fraction. This one's kind of messy, right? So we have to look at what is constant here, and we have AG is constant. So A and G, what are we going to do with those? Oh, there's the, great. A and G are constant, so we're going to pull those out in front, and we're left with R cubed to be the x-axis, and D is going to be on our y-axis. Separate those variables. That's it. You can linearize. There's some more practice posted.